Welcome. This is a video based upon mathematical induction and recurrence formula. So we do a couple of 7 questions based on that recurrence formula. So what is the question is given that? Given that un plus 1 equals to 5un plus 4, and also given that u1 equals to 4. Now I have to prove. I have to prove by induction. What I have to prove by induction? Un equals to 5 power n minus 1. So what is the first step I need to do? I need to have basis. What is this basis I'm going to do? I'm going to do basis as un equals to 5 power n minus 1 for this one. So let us plug in n equals to 1. So what does that becomes? U1 equals to 5 power n minus 1, which is 4, which is as given. Now I plug in n equals to 2. So u2 equals to 5 power 2 minus 1, which is 25 minus 1, 24. I need to prove that it is also 24 by using the recursive formula. So for that n equals to 1, so u2 will become 5un u1 plus 4, but u1 was 4. 5 times 4 plus 4, 20 plus 4, 24. So therefore the basis, what we can write it out is, so un is true for n equals to 1 and n equals to 2. Now what am I going to go for? I am going to go for assumption. What is that assumption? Let us assume that it is true for n equals to k. So 5 power k minus 1. Next I do for induction. In induction, what am I going to do? Take the right hand side, plug in k plus 1. Instead of k, k plus 1. And when you simplify it out, you should take left hand side and get that answer as k plus 1. So this should be your answer. Now for uk plus 1, go back to the recursive formula and plug in. uk plus 1 from the recursive formula will become 5 uk plus 4. 5 uk is from the assumption. What is that? 5 power k minus 1 plus 4. 5 power k minus 1 plus 4. So it becomes 5 times 5 power k minus 5 plus 4. I think so. That's going to be the answer. So conclusion, you can write it out. It is true for n equals to k and n is equal to k plus 1. By principle of mathematical induction, it is true. That conclusion, I'm not writing it out. Coming to question number 2. So again, it is given that un plus 1 equals to 2un plus 5 and u1 equals to 3. And what I have to prove by induction? Un equals to 2 power n plus 2 minus 5. What am I going to do for the basis? Take the formula which I have to prove it out and plug in n equals to 1. So u1, what does it becomes? 2 power 3 minus 5, which is 8 minus 5, 3. So it is correct. Then n equals to 2. So what do I u2? I get it out. 2 power 4 minus 5, which is 11. So I use the recursive formula also to get u2, which is 2u1 plus 5. 2 times of u1 is nothing but what? 3 plus 5, which is 11. Both are same. So therefore the statement is true for n equals to 1 and n equals to 2. Now what am I going to do for assumption? In assumption, what am I going to do? uk equals to 2 per k plus 2 minus 5. Now induction. In induction, take the left hand side and plug in k as k plus 1. And you have to simplify it further and get right hand side also k as k plus 1. 2k plus 1 plus 2 minus 5. So it should have become 2 per k plus 3 minus 5 should be your answer. So now again, uk plus 1 from the recursive formula. What is uk plus 1 from the recursive formula? 2uk plus 5. 2uk plus 5. 2 times of uk. uk is from our assumption. What is that? 2 per k plus 2 minus 5 and plus 5. So what does that becomes now? I move this one a bit down. 2 times 2 per k plus 2 minus 10 plus 5. I think so it becomes 2 per k plus 3 minus 5. Therefore, it is true. Conclusion, you need to write it out. Coming to question number 3. It is given. What is given? un plus 1 equals to 5u1 minus 8. Then u1 equals to 3. And we have to prove that un equals to 5 power n minus 1 plus 2. So I go for basis. What is basis? u1 equals to 5 power 0 plus 2, which is equals to 3. Then it is correct. So n equals to 2. So u2 equals to 5 power 1 plus 2, which is 7. Use a recursive formula to get 2. u2 equals to 5u1 minus 8, which is 5 times of 3 minus 8, 15 minus 8, 7. Therefore, the statement is true for n equals to 1 and n equals to 2. Now, assumption. For assumption, uk equals to 5 power k minus 1 plus 2. Now, for induction. For induction, what should I be doing it out? Take k as k plus 1 in the left hand side, and when you simplify it further by using the recursive formula, I should be getting it out 5 power k plus 1 minus 1 plus 2. This should be my answer. So from the recursive formula, uk plus 1 will become 5 uk plus 8. 5 times uk is assumption. 5 power k minus 1 plus 2 plus 5 power, this was 5 power minus 8. This is minus 8. So I write it out over here, minus 8. So it becomes 5 times 5 power k minus 1 plus 10 minus 8. I think so that is only the answer required. Now come to question number 4. It is given un plus 2. This time it is given as un plus 2. 5 un plus 1 minus 6 un. And he has given u1 equals to 1, u2 equals to 5. What is it being asked? Prove that un equals to 3 power n minus 2 power n. So first I go for basis. For basis I do u1 equals to 3 power 1 minus 2 power 1, which is 1. It is true. Then n equals to 2, it becomes 5 power 2 or 3 power 2 minus 2 power 2, which is 5. Using the recursive formula, find it out u2 also. u2 will be, or u3. So therefore over here we have to find it out u3 also, because my recursive formula first term is u3. So therefore in direct this formula also you have to find it out up to u3, which is 3 cube minus 2 cube, which is 19. Now use a recursive formula to get u3, which is 5 u2, means n equals to 1, u3 equal to 5 u2 minus 6 u1, which is 5 times 5 minus 6 times 1, which is 25 minus 6 is 19. Therefore it is true for n equals to 1, n equals to 2, and n equals to 3. Now our assumption. In assumption, what is that? uk equals to 3 power k minus 2 power k. Now assumption I have taken as uk equals to 3 power k minus 2 power k. Now I have to prove by induction. So what we have done it out, we have done u1 and u2 are been given. So what am I going to do it out in assumption? An extra step, uk plus 1 equals to 3 power k plus 1 minus 2 power k plus 1. In these kind of steps, two assumptions has been taken. Now inductive step. So plug in k as k plus 1. So it becomes u k plus 1 is u k plus 2. And when I simplify it out, in the assumption also, what is this? Plug in over here k as k plus 2. So what does that becomes? 3 power k plus 2 minus 2 power k plus 2 should be your answer. Now uk plus 2. Why I have taken plus 2? Because my recurrence formula starts with plus 2. So therefore my assumption also, and I should be accordingly. I will be able to use recurrence formula to prove it out. So uk plus 2 equals to nothing but what, according to the recurrence formula? 5 uk plus 1 minus 6 uk. Now 5 uk plus 1 is assumption. 3 power k plus 1 minus 2 power k plus 1. uk is also assumption. 3 power k minus 2 power k. So now I have to simplify this one further. So let me move this one down over here. Now, so what does that becomes now? 5 times 3 power k plus 1 minus 5 times 2 per k plus 1 minus 6 times 3 per k minus 6, then minus times minus is plus 6 times 2 per k. Now this 6 can be written as, we have to be very careful over here, minus 5 times 2 per k plus 1. 6 can be written as 2 times 3. So that 3 per k will be remaining as it is. Again, 6 can be written as 2 times 3 and 2 per k will remain as it is. Why am I doing like that? This 3, then what can I do it after? I want to make it out the like terms over there. So how do I get it out the like terms? So I have 3 per k plus 1. 3 times 3 per k. So I can do a color coding. 3 times 3 per k will become 3 per k plus 1. 2 times 2 per k will become 2 per k plus 1. So what does that becomes now? 5 times 3 per k plus 1 minus 5 times 2 per k plus 1 minus 2 times 3 per k plus 1 plus 3 times 2 per k plus 1. So what is the point of doing it out in that way? So I can group the like terms. I move it out over there. Then I can see that this term 3 per k, 3 per k. 5 minus 2 is 3. 3 times 3 per k plus 1. And whereas minus 5 plus 3 will become minus 2 times 2 per k plus 1. Which when you simplify it out, it will become 3 times 3, 3 to the power of k plus 2 minus 2 to the power of k plus 2. So see carefully for the simplification part. Then conclusion and so on, you can write that. Question number 5. It's given un plus 2. Again it is un plus 2. 6 un plus 1 minus 9 un. And u1 equals to negative 1. u2 equals to 0. I have to prove by induction un equals to n minus 2 times 3 power n minus 1. So first of all, basis step, what am I going to do? Substitute n equals to 1. N equals to 1, so u1 equals to, what does it becomes? 1 minus 2 times 3 power 1 minus 1, which is negative 1. It is correct. Now n equals to 2, it becomes u2 equals to 2 minus 2 times 3 power 2 minus 1, which is 0. That is also correct. Now n equals to 3. u3 equals to 3 minus 2 times 3 power 3 minus 1, which is nothing but what? 9. Now using the recursive formula also, I should be getting it out u3, because the first term from the recursive formula is u3. So you have to do till u3, which is 6u2 minus 9u1, which is 6 times 0 minus 9 times minus 1, which is 9. So therefore we can see that both are equal, 9 and 9. Now assumption. Assumption also, two assumptions you should do. So uk equals to k minus 2 times 3 per k minus 1, and uk plus 1 equals to k minus 1 times k minus 1, because plus 1 minus 2 will become k minus 1. K minus 1 times 3 per k. Now induction. So what induction? I will be taking it out uk plus 2. Next one will be nothing but what? K plus 2. So my final answer also should be equals to, when I simplify it out, my final answer should be plug in k plus 1 over here. So it becomes k plus 1 minus 1 times 3 power k plus 1. This should be your final answer. So take uk plus 2 from the recurrence formula. 6 uk plus 1 minus 9 uk. 6 uk plus 1 minus 9 uk. So 6 times uk plus 1, what is that? K minus 1 times 3 power k minus 9 uk. What is uk? K minus 2 times 3 per k minus 1. So I plugged in the values of uk plus 1 and uk. Now what am I going to do? I am going to take 3 per k common. 3 per k common. So what is left over? 6 times k minus 1 minus 9 times k minus 2 times 3 power negative 1. So I have taken 3 per k common. So what does that becomes now? Remember that this is our required thing. We will keep it there for a moment. So our next working will become 3 power k times 6k minus 6 minus 9 divided by 3. 9 divided by 3 is 3. So minus 3k plus 6. So what does it become? 3 power k times 6 and 6 gets cancels 2k, 3k. So I think so. That gives us this answer. Because 1 and 1 gets cancels, k times 3 power k plus 1. So we have able to prove that one. Question number 6. Given that again un plus 2 equals to 7 un plus 1 minus 10 un, and he has given u1 equals to 1, u2 equals to 8, and I have to prove that un equals to 2 bracket 5 power n minus 1 minus 2 power n minus 1. So first n equals to 1. N equals to 1, so u1. What does it becomes? 2 times 5 power 0 minus 2 power 0, which is 1. That is correct. Then n equals to 2. So u2 will become 2 times 5 power 1 minus 2 power 1, which is 8. That is also correct. Then n equals to 3. u3 equals to 2 times 5 power 2 minus 2 power 2, which is 46. Now using the recurrence formula, I have to prove that u3 also correct. Equals to 7 times u2 minus 10 times u1, which is 7 times 8 minus 10 times 1, which is equal to 46. Therefore, the statement is true for n equals to 1, 2, and 3. Assumptions. In assumptions, two assumptions. One is for k and one is for k plus 1. So uk equals to 2 times 5 to the power of k minus 1 minus 2 power k minus 1. Then plug in k plus 1, uk plus 1 will be equals to 2 times 5 to the power of k minus 2 to the power of k. Now induction. For induction, after k plus 1 it will become k plus 2. uk plus 2 should be equals to, or else let me write it out on a fresh page. So uk plus 2 should be equals to, plug in the right side also, k plus 1. So it should be equal to what? 2 times 5 power k plus 1 minus 2 power k plus 1. 2 times 5 power k plus 1 minus 2 power k plus 1. This should be the answer. Now use the recursive formula to get this one. uk plus 2 will be 7 uk plus 1 minus 10 uk. 7 uk plus 1 substitution is 2 times 5 power k minus 2 power k. 2 times 5 power k minus 2 power k minus 10 times uk substitution. uk substitution again is again nothing but 2 times 5 power k minus 1 minus 2 power k minus 1. Now we have to simplify this one. What does it becomes? 7 times 2 is 14 times 5 power k minus 7 times 2 power k minus 20 times 5 power k minus 1 plus 10 times 2 power k minus 1. See the requirement. I require 2 times 5 power k plus 1 and 2 power k plus 1. So first I'll take 5 power k common in this both. So if at all I take 5 power k common, it becomes 14 minus 20 times 5 power 1 minus 1. Then I take 2 power k common. 2 power k common. So it becomes, or negative 2 power k common, better. Negative 2 power k common. So it becomes 7 minus 10 times 2 power negative 1. So when I simplify that, what should I be able to get it out? 5 power k, 14 minus 20 times 5 power minus 1 is 4. 20 by 5 is 4. Similarly, minus 2 power k times 7 minus 5. So what does that becomes? 10 times 5 power k minus 2 times 2 power k. 10 can be written as 2 times 5. 5 power k minus 2 times 2 power k is 2 power k plus 1. I think so this is the next step. 5 times 5 power k is 5 power k plus 1. So again, write the conclusion. Last question, question number 7. It is given un plus 2 equals to 6un plus 1 minus 9un, and u1 is given as 3, u2 is given as 36, and the formula which we have to prove is un equals to 3n minus 2 times 3 power n. So basis n equals to 1, so u1 will be equals to 3 minus 2 times 3 power 1, which is 3. N equals to 2, u2 equals to 6 minus 2 times 3 square, which is 36. Now we have to go one step and get it out, u3 also, which is 9 minus 2 times 3 cube, which is equal to 189. Now use a recursive formula to prove that u3 equals to 6 times of u2 minus 9 times of u1. 6 times of 36 minus 9 times of 3. It is still 189. So therefore, it is true for n equal to 1, 2 and 3. Assumption, two assumptions should be done. uk equals to 3k minus 2 times 3 power k. uk plus 1 equals to 3 times k plus 1 minus 2 times 3 power k plus 1. Now what am I going to do? Plug in k plus 1 over here, so it becomes uk plus 2 should be equals to, when I write over here, it should be equals to, plug in that one value in the right hand side also, it should be k plus 2 times 3 power k plus 2. This is the formula. Over here in the assumption also, we should be plugging k plus 2 over here in the right hand side too. So I have to prove it. Now uk plus 2 from the recurrence formula. What is uk plus 2 from recurrence formula? 6 uk plus 1 plus 9 minus 9 uk. Minus 9 uk. So 6 uk plus 1, plug in the value, 3 times of k plus 1 minus 2 times 3 power k plus 1 minus 9 uk. 3k minus 2 times 3 power k. So what does that becomes now? 6 times 3k plus 3 minus 2 times 3 power k plus 1 minus 9 times 3k minus 2 times 3 power k. What can I take common? I can take 3 power k plus 1 common. So 3 power k plus 1 is gone. So what am I left with? 6 times 3k plus 1. From where this 3 power k plus 1 will come over here, because 9 can be written as 3 times 3. That 1 3 and 3 power k will become 3 power k plus 1. So what am I left with? Negative 3 times 3k minus 2. So it becomes 3 power k plus 1 times 18k plus 6 minus 9k plus 6. So it becomes 3 power k plus 1 times 9k plus 12. In 9k plus 12, what am I going to do? I am going to take 3 common. So it becomes 3k plus 4. So see, 3 power k plus 1 times 3 is nothing but what we can clearly see. This will become 3 power k plus 2. And this will become 3k plus 6 minus 2 will become 3k plus 4. 3 times k, 3k plus 6 minus 2 will become 3 power k plus 4. In this way, we can able to prove that. So this completes some questions based on recurrence formula on mathematical induction. See you in the next video. Bye.